Last night, I undertook an investigation of why I was having this problem in the animation system. If you look at the dude, his arms are actually stretching and unstretching as he rotates just a little bit. And that's not good. And after some investigation, I discovered that the reason this is happening is because I am dumb and I'm doing a transformation, or I'm doing an initial animation interpolation in object space instead of node local space. And it's just the wrong thing to do because you get much worse linear approximations of things in object space than you do in local space. So we have to fix that. It shouldn't be too hard to fix it enough to remove this artifact. And then the question is, how far do we push that into the system in terms of making it better? There's a weird red mark in the middle of the window. Yeah, so what's going on there is, let me do, so you can sort of see the guy, like through the, mostly when his arm is going in like this way, you can see red there. That's like his feet. Because we haven't, we have this shader to draw characters behind objects so that you can still sort of tell where your guy is when you're behind a big foreground obstacle. And it's not smart enough yet to ignore the character himself. So what you're seeing is like us drawing the feet as like, oh, you could see this guy now because he's behind something, but he's behind himself, right? So, that is to be fixed a little bit later. Will using stencil buffers fix this? I mean, a stencil buffer is just like any other buffer these days, so it probably doesn't matter. Using a stencil buffer-like technique might be a thing. Will using blockchains fix this? Yes, by ensuring that your game never runs fast enough that anyone can play. Okay, so what we have to fix is the following thing here. First, we are we're calling getXForm state. And then we're saying get the local state relative to the parent. All right. So what we want to do, I guess, well, let's look at getXForm state. It actually gets a whole array of XForm states, puts them in this result called states. Really what we want to do is instead of evaluating them in object space, right, we can convert each one into local space and then interpolate. And then we can push this further. Like at first we can do the interpolation to local space here, and then later we can like push it up the tree, right? So let's just factor this into a procedure. So we'll say relative state is get relative state animation states it index, right? I think that's all that we need. And then get relative to parent actually, let's do this. I don't know which way to factor this. That's fine. Like that. What is this? So, well, let's just not make us. Let's not even think about it. So we're going to pass the animation. We're going to pass the index and the states. What are these? Xform state. Okay. So we're going to say ainf, we're going to do this. And just paste all that. So we're going to say state is state sub index. It's not it index now, it's index. And we get rid of this because we're just doing by value. This routine doesn't necessarily have to be that fast right now. Because it's just a front end to this thing, right? And now instead of adding it to an array, we return it. Okay. Okay. Okay, so now we've turned this old loop into this. And we're not even using this variable state. We could just iterate over the indices. Undeclared identifier, get relative state. Oh. Okay, so now we should be still the same. Yep. We're still playing back animations. It still has the problem because we haven't actually changed anything yet. All right. So the next thing to do is to tweak get xform state where well, does anyone else call get xform state? Like, how much can I change this? It's only called in this file. All right. Well, we're going to pass So instead of this, we're going to go array resize. I don't know if that's how that works. Okay, apparently it is because we didn't complain about that. So now states relative to parent. Okay. Let's get rid of all our debugging code here that we don't need. Okay. Okay. So oh, you know what? This is, we don't need two arrays because we're not using that states as the source. So I'm just going to do this. Okay. So states it equals, what did we call it? Get relative state. Anim. It. It's confusing because we have two indices. We have our node index and we have our sample index. We really should call this sample index. Right? It makes, on the one hand, it looks a little harder to read because there's a little more text, but actually, you might easily look at this and see the word index and go, oh, it's the node index or something, right? So we're getting the relative state from states, or node does. Right? That's in the case where we're getting an endpoint. Otherwise, we do this. M0, M1 is get relative state. Now I'm confused. I'm still getting my indices crossed because this was sample index here, right? But this is node index. Okay. I think we might have a situation where the storage is different. Now I'm regretting eating all that sugar because my brain is confused. All right. Right, so I don't think I can do it this way. I did all this thing to wrap this up into this routine. And this routine is not actually the API that we want because the data is stored differently. Here, it's for every node we have for every node we have an array of frame data on that node. Whereas this one is like, if you've just got two arrays of sample data ordered by node index. So this kind of wants the opposite storage. So really what we just have to do is like unfold this into here, which is a pain in the butt. But it's fine, honestly. So, actually, we want to unfold it here. We want to get the relative state for sample index plus 0 here because we use that in both, and then we can get sample index plus 1 in here. Okay, so global of I don't know what to call my variables. Node global is node.states light sample index. This is node index. So we're going to say, we're going to call M0, right? Not -1, dot dash dash dash, uninitialized. So we get the A info if A info.parent index is greater than or equal to 0, else M0 is node global, right? If we've got a parent index, then relative state is, or no, M0 is get, not colon, get relative to parent node global parent global. Let's call this child. Okay. So get relative to parent child global parent global. So parent global is node.states light A info.parent index. Maybe this would be more readable if we just folded it in. And if we change this to just node.states, because we don't need this to be called states light. There's no heavy states anymore. Anyway, so that in principle gives us M0. And here, there, and then this is just M1. Hope I don't mess this up too bad. Wait, what did this used to say? Yeah. M1. Yeah, so we're going to say child 1 global. Now this hasn't changed. And we'll get parent global again, even though this is redundant with what's up above. And then we say M1 is child 1 global, child 1 global, parent global. Okay. Will that work? I probably screwed something up. I mean, let's be honest. I almost screwed something up several times. Max sample index. Oh. Where did that? Oh, because I renamed index to sample index. All right. M1 X form state is blah. And then we don't need to dereference these anymore. Array bounds check failed. Oh, yeah. No. This is sample index. Okay. Parent node is node info, ainfo.parent index, right? And this is parent node sample index. I'm sure glad we had an array bounds check there. Okay, well, he's got the shakes. So that's not good. Wow, okay, we're doing something real bad. This is not what you want out of an animation system. This looks like what happens when you kill the horses in Scum. Yeah, this is pretty weird, right? Like, usually if you mess up animation, you just get everything crunched into the root node or something. You don't usually get something this entertaining. I feel like the only way for this to happen let me just review how I'm using the return data here. Okay, this is weird. Yeah, let's make sure we're not using this. Okay, well, That's not going to fix anything. This is pretty weird. It's like we're mixing up node index and sample index some more. Like lower down in the hierarchy, he's turning less. Like down toward the stomach. And then he's turning more the further away you get. So like, yeah. That's all pretty interesting. So I need to rename these variables so that I'm less confused about them, right? So let's say, let's change this if just to reduce the amount of code, right? All right. So we'll do the same thing if parent node, then, oh, dude. This is supposed to be sample index +1. So yeah, yeah. That would be not what you want. Hey, look, he doesn't have the shakes. Hey, look, his arms are no longer stretching and contracting. How great is that? Effect ruined. Sorry, it was a pretty cool effect. I admit it. It was a cool effect. It was like Wolverine Simulator. Okay. Clones still don't animate. This clone in the upper right kind of gets a limp when I... Maybe they all kind of have a limp. So we have to deal with that. Would I ever consider rendering a reflected version of the world to display in the magic mirrors? I don't think so. And the reason is because if you're actually being accurate about that, the camera's above the scene the whole time, so you're only ever going to see a little bit of the ground. It's not going to be that interesting. You're going to pay a large cost in order to see a little bit of the ground at an oblique angle. Oh. Yeah, so this is good. I can check this in, and then we'll make it better. So now, instead of doing this this is not just every frame, right? It's every sample for every frame. So we're doing this relative to parent situation 2 times 140 times per character per frame, or however many bones they have, right? Times 2. So in a scene with 5 characters, we might be doing this 2,000 times a frame, which is not that much, but yeah, no, we want to do less than that. So my next step is just going to be to do this conversion at load time instead of here. And I'm going to do some renaming. So I'm just going to call this states instead of states light, because that's a historical name, I think. So yeah. There used to be a heavy state, and we don't have that anymore. Haven't had that in like a long time. So we're just going to rename this. And now that there's no longer an array called states, well, maybe there will be again. Maybe I'll rename states relative parent to states, but I could call it states by node or something. The thing is, these 2 arrays have different storage, so naming them exactly the same is a little bit not what you want. Okay. So let's make an if-def. We'll say pre-transform to relative is true. So we're going to say if pre-transform to relative, else we do what we're doing now. And the pre-transformed to relative version of this is just going to be M0 is node.state sample index, right? Um, how did this go before? I feel like we didn't have the parent computation in here. Or no, okay, obviously we don't, right? So this is just M1 is this, and then that, right? So this is what we want to get to. Do you want to see something entertaining? Let's see what happens. This is going to be another messed up thing because we're playing them back as if they were global, but they're relative. So this is going to be a giant mess. It's going to be some Hellraiser situation. Oh. Ugh. Ugh. Let's try levels where guys are smaller. Yeah. Oh yeah. This is what happens when you really mess up your animation system. At least we don't have any triangles going to infinity. That's always fun. They're all like in... Oh, we're not. Okay, in the editor, we're not actually playing the animation. Okay. So we want to get to the point where this is turned back into this, right? Looking at this, you can imagine how that's faster than that. Especially as this calls some other procedures, right? Okay. So we don't need this anymore, right? Nobody calls that. And this, we're going to put here just because, oops, that's what we need. Oh, no. This is going to mess up our foot matching. I hadn't thought about this. I have to redo foot matching today. Because, you know, so what happens a lot of the time is you play some animation and then you're like, hey, let's segue into this next animation. And you want to figure out where in that animation to play from. You can match the positions of the hands and feet. Well, since our animations used to be in object space, then you used to just be able to look at the node translations to figure out where things are. And now we have to fix that because those have to be multiplied into object space. What a pain. But we're not going to do that yet because right now we just need to handle this. So load, where do we load? Here's where we load. So we load each node one at a time. Now let's just look at the file. So here's all the nodes. And then we have a keyframe, and each keyframe is one sample per node. So here, we do it here. All right. So if we pre-transform to relative, we do some stuff, else we do other stuff. So we read into a child, we get the parent. Your parent node is always guaranteed to have a lower index than you. So we know the parent node is loaded. So, well, let's go back to so we get the parent index. If parent index is greater than or equal to 0, else, oh no. So the problem is we can't do this in order from left to right because we'll have destroyed the parent node data when we want to use it for the child nodes. So we actually have to read the whole thing. And then maybe we go right to left. Change the file format to be relative, bro. Okay. So if we're pre-transforming to relative, then actually let's put this out here. So we read these. These are all in object space, no matter what. Then we iterate in the reverse order over this stuff. And instead of read X form state, well, we say child is okay, so parent index is a_info.parentIndex. Not that much worth putting its own variable, but whatever. a_info.states sample index. Parent, if parent index is greater than or equal to 0, index anim dot a_info.states sample index equals get relative to parent, get relative to parent, child, parent. So now we're doing it right to left. So go go right to left so that we do children before parents. Okay. Probably messed it up. Yep. This looks the same as before. Why? It doesn't look any different. I don't understand why that wouldn't do anything. Oh God. I think we're taking a copy of this entire struct by value and then writing into the value copy and throwing it away. Nope. Nope. So weird. Oh, it wouldn't matter because the array... Yeah. So that's what I thought. We never actually run this code for some reason. Pre-transformed a relative is true. Oh, okay. Yeah. Well, okay, now I've got my indices crossed. I've got a bone index where I've got an animation index. But, yeah, when you... Yeah, I forgot to reverse the order of my guys. Okay. It's debatable about whether this should be this way or the other way in general language semantics, but for now it's that way. Okay, so line 240. We can take out our print statements because those aren't going to be necessary. Parent in... Oh, yeah, no, this is sample index for both of these, but we're going to say pinfo is anim.node info parent index. It's so easy to get confused when you're programming. I don't know why. It just is. Look, this is an actual human, sort of. It's an actual human. Yeah, see how it's super jumpy right now when he starts moving? It's because the foot matching is all frickin' hosed. So we have to fix that. We have to fix the foot matching. All right. Well, let's just say, since we got this working, that's that. This all goes away. And there we go, right? Oh. You always know it's been successful when your code did its job and therefore you get to delete it. Yeah. Yeah. I don't know if it's only the foot matching that's causing that teleport right there, but it may be. Maybe. Okay. We might want to do foot positions here while we have everything global, because otherwise it could get very expensive. Let's think about this. First, I have to send an email. I'm just getting bombarded by emails that I don't want. Don't want any of your people's emails. Anyway, so we've had good success here. Oh, I gotta tell. Okay. Ah, my tea's cold. My hot tea is cold. Okay, so let's look at our footstep situation. Find closest matching time. I don't know what relative to name means. Let me see who calls this. Left bone, right bone, base. Okay, so right, we're matching 2 feet or 2 arms if we want to use them for arms. Right now it's always just ankle bones relative to the root bone. So this is a pain to do on the, like, not at loading time, because if we've only got our animation data in relative space now, then, you know, to get the translation relative to some other node that's far away, you have to basically, essentially, you've got to compute the object space of everybody. It's not great. Speed-wise, because you have to do it for every sample in the animation, because the point is you're finding a time within that animation, right? So it's not awesome. It's not awesome. So really what I want to do is, for every animation, I want to just have the foot positions. We're just going to do that on load for now. I guess that's something that we could save in the animation file as well. But we just get the foot positions relative to the root. You know what I'm saying. And we'll just hard code it for the feet for now. And if we need to expand on that, we'll expand on that. Have 2 sets of data, everything in relative and foot and hand in object. Well, yeah, it's just we don't. That would be a straightforward expansion of what we're about to do, because the question is, you could answer the question of how much data do I need to save to do pose matching? And if it's very sophisticated pose matching, you might want to save all kinds of things, right? But it's probably not the raw animation data most of the time. I don't know. Like here, we're just saving translations. So let's just start butchering this. This is all the same. So first of all, this averaging is not useful, right? Almost all of this procedure remains the same. The only thing that we really need to do well, I mean, okay. Actually, what I just said is not true. Like, as we play back the animation, either we want to interpolate the foot positions. Like, there's two things you could do. You could take your guy and say, we're going to extract the current foot positions from the object space, which actually we have because you need the object space to render, right? Or you could maintain foot positions in a totally different situation. Yeah. Okay. I'm just rambling at this point. Anyway, these are still in object space because these are the states that happen after we've concatenated everything back together. So these are still in object space. These are not. So yeah, really all we have to do is what I was saying. We just have to have the footsteps pre-computed on the animation. So what we would do is just say T0 is animation.footstep pause left, foot pause left of I, right? And T1 is, or what am I doing? T0, T1, these are translations. So T right, usually T means time. So we have these foot positions. And then we take the distance there, okay? So we need to make those. You know what I'm saying? Okay. Now, when we load, before we convert to relative, Okay. Um, So now some animations will not have corresponding node indices. Yeah. Okay. Because we load animations for more than human characters as well. What a pain in the butt. All right. So here, okay, we fill out the node info. All right. So we need find node anim left foot name, right? Node right foot is find node right foot name. Node feet relative to feet relative to name. So why are we making those constants? Well, those are going to be these, so that we use the same frickin' things. And then here, okay. Because now we have two parts of the code that are pretty far apart that are both using these names. So we get the right foot, the left foot, the feet relative to. Okay. So if node left foot and node right foot and node feet relative to, then we do some things, right? We do this. So let's say x0, x left is node left foot dot states sample index. Right? Is that right? Something like that. I don't know if that's right, but anyway. Okay, so we get these two translations, and then we say, well, foot pause left sub sample index is to the left. You dig? You dig? Okay. How much did I screw up there? Well, it compiles. I don't know what that means. Well, we crashed. Oh, because we never assign. We did all this stuff where we make these arrays, and we never actually assign them to the animation. All right, well, he looks kind of jumpy sometimes still, but I don't know, man. This doesn't look right at all. Let's see what... here we go. Are we in the wrong HUD? Yes, we're in the wrong HUD. I'm looking for game report. Okay, so if I match... well, we're getting different times in the animation. Like a good sign that it's not working is that you don't get different times in the animation. Now what we really want to do is maybe match into the middle of that, but I don't know. These still look suspicious to me. do that? I don't know. Wait, what's our distance being reported? That seems like a reasonable distance, 1/10 of a meter. Well, it gets high sometimes. Well, it actually doesn't look bad. Oh, that was bad though. What's going on with these blends? Is the blend time turned way down, or? That was big. So he was going to idle. So if I'm there, okay, hold on. How do I make this happen consistently? Now it's just not happening consistently. That was, okay, so I was right, going to idle, down. Didn't do it that time. Did it that time. It's when the matching is 0. It's like if the matching time is 0, then we snap. Seems weird. Or if it's low, if it's 0.06. That's like a different problem. Wait, that time? I don't know what's going on there. Let me just check this in because it does seem better, but not done. If the model is not at rest and key is pressed, dist is less than 0.43. Use the next floor's position. What are you talking about, use the next floor's position? I have no idea what you mean. Could I somehow get California to build more houses? I wish. That is the number one thing California needs to do. Unfortunately, it's not happening. Dist is the position of model when you press key. You should use position of floor. No, dist is not position of model when I press key. That is not remotely what that is, unless there's a horrible, horrible bug. Although that said, a distance of 0.4, I mean, that's the sum of total distance between the 2 feet. Like a distance of 0.4 is 0.2 for each foot, which seems like a lot. But that's not the problem I'm even looking at. The problem I'm looking at is this discontinuous jump that happens there. Like we're supposed to be smoothly blending. What the hell? See, the problem is, I don't know if there's something in the animation graph that's not controlled by me that is causing this. hope not. Okay. There's fucking blend 0.0s in here. All right. I'm writing an email right now, and I'm saying I fixed, hopefully, the foot matching, and then was noticing that characters are discontinuously popping between poses all the time, and it looks really bad. After being confused for a while, I thought to look in human.animation graph, and well, there are a bunch of blend 0.0 times in there when switching between different states. A blend of 0 is guaranteed to look like teleporty crap, and we do not want to ship a game that does that. What's the motivation behind this? There sure are a whole lot of them. All right. It's very hard to be nice writing emails sometimes. It's definitely a problem that I have. Yeah, I don't know. It's quite likely that this was added for some perceived reason. You know, like you don't just type that for no reason. we'll have the conversation first, because it's not going to tell me that much if I look at the history of when these changes were made, because that doesn't tell me why and so forth. Yeah, blend time of 0 just means snap to that. Oh, I will say, oh, did this have to do with trying to deal with the turning thing? We totally do not want to do anything like this. It's not the right way to try to handle this problem. Though that said, blending is going to mess with turning. No matter what. So if turning compensation built into the animation is really what we want to do, we need to do it in some way where a base turn node is marked not to blend, which seems unworkable. Maybe I am not thinking about it properly, but it seems likely that we will want to do this in a less hacky way if we want a good result. All right. Well, yeah, exactly. The only situation you would actually want 0 is under the very precise condition that you're playing a next animation that continues from the previous one. Yeah.